Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over the stoichiometry of electrolysis. So let's get into this. This is going to be a short video. So when we're thinking about the stoichiometry of electrolysis, we got to also consider that electrical current is used to drive a chemical reaction, right? So you are using a certain amount of charge, you're adding electrons to get a reaction to go. And so, in this way, the electron can act as a reactant, and therefore, the amount of electrons is going to have a stoichiometric relationship to the other reactants and products in the chemical reaction that you are trying to drive. So, let's use an example to make this clear. So, let's take the example of electroplating copper onto a certain metal. Let's say you want to add a copper plating to, I don't know, let's say a spoon of some sort. What would you do? So here is the reaction that we're driving. We want to take copper ions and make them into neutral copper atoms that are then going to be added to the surface of whatever metal that you're interested in plating. And so we know that we have a stoichiometric relationship between the amount of electrons and the amount of atoms of copper. So here I have the relationship here. So for every 2 moles of electrons that is picked up by the copper 2 ions, 1 mole of copper metal is formed on the surface of your metal object. So you can take that relationship and you can convert between moles of electrons and moles of copper. So let's say if I'm given a problem where, hey, you are running a certain battery with a certain amount of current, right? They give you the current, and we have to remember that the unit of current is 1 amp uh, or 1 coulomb per second. So if I give you the amperage of the current, say, hey, 20 amps or zero point 0.2 amps or whatever the amperage is, that's giving you a certain coulombs per second that is flowing, the electrons that are flowing through the wire. And so I can use this if I know the current and I know the amount of time that I'm running the current, that I'm hooking up the battery to my electrodes in order to get the electroplating to occur. If I've got the time in seconds and the current, then I can multiply those two together and I can get the total amount of charge of the electrons that flowed during that time. And so then I can use Faraday's constant, which is also gives me a stoichiometric relationship that 1 mole of electrons is going to be equal to 96,485 coulombs. So if I can use the current and the time to find the total charge in coulombs, then I can use Faraday's constant as a conversion factor to convert coulombs to number of moles of electrons. Once I get this, now I can use the moles of electrons to moles of copper to convert to moles of copper that was plated onto the surface of my metal. And then if the problem is asking for, hey, how many grams was plated, how many grams of copper was plated on your metal, then you would just use the molar mass of copper to convert from moles of copper to grams of copper. So that is how you can use the stoichiometric relationship between the electrons that are being flowing to create a solid metal, as an example here. So this is just one example of how you can use the stoichiometry to answer questions in electrolysis type problems. So I hope this was helpful. In other videos, I'll go over example problems where we use stoichiometry to solve redox reactions or electrolysis reactions in certain situations. So if this was helpful, please, by all means, like this video, share this video, hit that like button right there. Also, subscribe to my channel, hit that notification bell right up there. Also, don't forget when you hit that notification bell, click all so you could be notified by all the videos I put out. And also make sure you put a comment down below in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me, and have a great day.